Hello everyone, I am Dr. Shukanto Devnath, Assistant Professor, SIT College of Engineering. In this video, I am going to discuss about eddy current, Faraday's laws of electromagnetic induction and grip rule. So before starting eddy current, I am to discuss this one circuit. Suppose we have a coil and beside that coil one magnet is placed. Now if we move that magnet, the magnetic value will change. So to oppose that change in the coil, one current will be induced due to the electromagnetic induction, and there will be a direction of the current, maybe in the clockwise or anti-clockwise direction, and there is direction in the galvanometer also, maybe is in the positive or negative side. Now this current is getting one closed path to flow. Now, why this current is induces, and what is the direction of the current, and what is the direction of the galvanometer? So these things we need to know. So that's why I want to explain a little bit about the Faraday's law. So according to the Faraday's laws of electromagnetic induction, if there is any relative motion between that magnet and coil, EMF will be induced, and because of that EMF, there will be a current flow. Now, if we consider one circuit, suppose this circuit where both are in stationary, means there is no relative motion, so no EMF will be induced, no current will flow. Now, if we consider the next circuit where uh, one this magnet is moving towards the coil, and in the second circuit magnet is moving away from the coil. So when in the first condition, when that magnet is moving towards the coil, so there is a relative motion between this, and EMF will be induced. Because of that EMF, there will be some current flow, and galvanometer deflection. There is some deflection. That galvanometer deflection is in the clockwise or in the right hand side. Now, if we see the other diagram where that magnet is moving away from the coil, so again there is a relative motion, and EMF will induced, current will flow, but it is in the opposite direction, and the galvanometer displacement also reversed. Means in the previous case it is in the positive side, now it is in the negative side. So this is happening. So here you can see in the coil there will be some pole. It is creating some pole, south pole and north pole. So when there is a change in the magnetic properties because of that magnet movement, so when it is moving towards the coil, this coil is creating another north pole. So it will oppose that change again in the next circuit. So when that magnet is moving away from the coil, so to stop that change, it will create the south pole to attract that magnet. So these things we can find out by using that right hand grip rule. So what is that right hand grip rule? So if we see, consider that figure 3 where we can see one solenoid. So if we grip the solenoid using right hand and curl the finger in the direction of the current, here current direction is showing in the upward direction. So if we curl the finger in the direction of the current flow, the extended thumb direction is in the north side. So based on this, we can say in the figure 1, so when this thumb direction is the right hand side, so that's why this north pole is in right hand side and south pole in the left hand side. And in the figure 2, the thumb direction is in the left hand side, so that's why north pole in the left hand side and the S pole is in the right hand side. So by using that grip rule, we can find out the field direction also. Now if we see the figure 4 where one green color wire is there, so in case of that grip rule, the if we grip the wire using the right hand such that the thumb point the direction of the current flow. So in the first diagram, if the current direction is in the upward direction, and so that's why the thumb direction is also in the upward direction. So here we can see the direction of that magnetic field. So it is in the what anti-clockwise direction. In the second figure, when that current direction is in the downward, so in that case that direction of the field is in the clockwise direction. So by using this right hand grip rule, we can easily find out the direction of the current and direction of the field. Now finally, I will discuss about that eddy. What is main basically that eddy current? So if we compare this diagram with the first diagram, this diagram. So in this, if we consider one coil, here we have considered one coil, and in this diagram we have considered one metallic plate. So in case of that coil, there is some closed path. So whatever current is induces, so it will because of that closed path, it is getting the path to flow. But in case of that metallic sheet, so whenever there is a relative motion, so there will be some current will be induced. So this current, in case of that plate, this plate don't have any closed path to circulate the current, so that current will starts creating small loops like this circular currents in the figure showing in the figure 2. It's create small loops in the metallic plate like the eddies in the water. So this circular current is called eddy currents. So basically, in case of that coil, there is a one closed path, so that's why current is flowing through that closed path. But in case of that metallic sheet, there is no closed path, so that's why it is creating the loops in the plate. So these loops of currents, or what loop, the circular currents, we can call that eddy current. Now, what is the advantage and disadvantage of this eddy current, and how we can reduce this eddy current loss? So what is the advantage? So by in case of that eddy current, so by using that eddy current testing, so that is one test which is very flexible, and this is a non-destructive test. So by using that, we can easily find out the flaws in the material, such as if there is any cracking, corrosion, erosion, and the material deterioration or thickness loss. Everything we can find out by using this test. So this is the one advantage of this eddy current test. Now, there are some disadvantages of these eddy currents. That is because of these loops of currents or eddy currents, some heat will be generated. So there will be a energy loss in the metallic plate, or because of that heat, so it will damage the insulation also, and some unwanted damping effects might result from these eddy currents. So these are the different disadvantages. Now, how to reduce these eddy currents? So basically, by using the if we whatever sheet we are using, if we laminated that sheet, so we can easily reduce that eddy current loss. And if we consider, in case of considering that whole plate, if we reduce the area, so if we, in the below we can see some figures where we can cut the middle part or side part to reduce the area of the plate. So by using that, we can reduce the eddy currents. And in case of the transformer, so many number of laminated sheets are used to reduce that eddy current loss. So from this video, we can understand what is eddy currents and what is Faraday's law, and what is that right hand grip rule, and by using that right hand grip rule, what we can find out? We can find out the direction of the current and direction of the magnetic field. So these are the some references. So from if you have any doubts or any queries, please comment me. Thank you.